Okay, I think I have another good one for you parents out there. We worked the summer and we talked about how the way we've been practicing, for Natalie at least, for our mathematical multiplication facts, maybe what we've been doing hasn't been awesome. So one of the techniques that many experts have suggested, and I really loved, was the idea of, maybe still using flashcards, but using a different approach. So what I did for Natalie, because she's a very visual child, very visual learner, is I created, my own little set of flashcards where I set up, where I had matches, so pairs. And they came out to the same product. And as you can see, this is a picture of it, but most of them are just written as math facts, multiplication facts, and a couple of them are drawn as really horrible arrays because I cannot draw. But, you work with what you got. And we kind of had a giggle about that. She's like, "Oh, Mommy, these are awful." And I said, I know. So you have to be a little careful in your selection and your creation of these. Make sure everybody only has one match. But she would go through them and match them. And I would, in the future, I'm hoping to get her to do this live so I can record it and you guys can see how her brain works through them and how she justifies it. But you get to have some really powerful conversations with them when inevitably those mistakes occur. When she tries to tell me that 9 times 4 is going to be the same thing as, 4 times 5. And then we look at that and we go, "Oh, Natalie, that, let's think if that makes sense. 9 times 4 is the same thing as 5 times 4. And then she goes, "Oh no, that wouldn't make any sense." Or, I've heard her say things like, "Oh, well, 9 is a really close relative of multiplying by 10. So it's kind of like 10 times 4. And then she, can kind of manipulate her math facts that way so she can understand the groupings of the fact families rather than just memorizing them. That's the goal. The array is a visualization of the multiplication problem. So, if she really got in a jam, sometimes she counts up what are supposed to be squares. They're not squares. Sometimes she'll just count the dimensions and tell me, it's 3 by 8, and that means 3 times 8, which is 24. That's awesome. I'm glad she knows that. Sometimes we're not that lucky. Some of the cards you notice are just the products themselves. There's a 21 and a 72 on the example I did here. I really loved this, and I keep using this same set of cards with her, for a period of time, and they're color coded. So I have a yellow set, I have a blue set, I have a red set. I just made them with construction paper. I'm not real fancy. So we've had a lot of fun with these. She I won't say it's her favorite task to do, but definitely better than traditional flashcards for her. And what I did with my son, so I just took his flashcard stack, and because some doesn't really have great visualizations because they really just turn into counting problems at that point. But I just took his flashcards and I found a pair that added up to 4, up to 5, up to 6, up to 7, and just found what I found as I was going through the sort. And I just laid them out and I said, "Okay, let's match them up, buddy." And just hearing the way they process their math, because the children they'll always do it like verbally. And it's really awesome as a parent, or as if you're a tutor working with the child, to hear how they're filtering through the information in their head and how they're organizing their thoughts and giving them that chance to justify it. And, going back to Natalie's set of cards, sometimes, she'll get crafty with me. And she'll say, "Well, I just know that 9 times 4 is 36, which is okay. You know the math fact." And I play devil's advocate and I say, "I want you to convince me that 9 times 4 is the same thing as 6 times 6. So I'll show on another example on a different video when hopefully Natalie works with me, but how we actually break down the factorization of 9 times 4. And we call it, 3 times 3. And then we break down 4 by calling it 2 times 2, and then we kind of regroup the factors to show that it really is the same thing as 6 times 6, which is kind of awesome. So I know there's parents out there who are like, "What should you say?" I'll show that in a different video, but I think this technique for flashcard matching is just more powerful than traditional flashcard memorization. Another way you can step this up is you can make this into a memory game. So you could turn them upside down if they're blank on the back. And if your child needs a little extra challenge, you can do it that way. Natalie has not wanted to do the memory component of this. She claims to have a very bad memory. I respectfully disagree, but we're not there yet, and that's okay. So give this technique a try. You really, you don't need to throw out your flashcards. Just keep them and use them a different way. There's definitely more flashcard games out there. Go look on Pinterest for flashcard games or flashcard techniques, and you'll find out that there's some really creative people out there who have come up with some really awesome things that let your child foster that conceptualization of the math that we're looking for. All right, if you enjoyed it, share it.